Okay, the square root of 3 minus I raised to the 4th power. In case you saw this in the previous video and you want to see if you have the right answer, I'm going to put the answer right here. So some of you are saying, yes, I've got that. And others are saying, can you show me how you got that? Absolutely. So I'm going to start with, this time I'm going to start with plotting it, just because it looks a little different. So it's going to be in quadrant 4. So the square root of 3 is about 1.7-ish, I believe. And then down 1, so we're going to be somewhere right here. So most definitely that point is closer to the x-axis, or not the x-axis, I should say the real axis versus the imaginary axis. But in my calculator, if I were going to estimate this angle, if I just had to take a wild guess what this angle is, with that square root of 3 being there, I'm thinking that I've got a pi over 6 angle. But jumping way ahead of myself, these are just thoughts I have as I'm drawing the picture and getting some ideas. I'm going to actually do the computations. R is equal to the square root of 3 squared plus negative 1 squared. And that's going to give us the square root of 3 plus 1, which is the square root of 4, which reduces to 2. So R is equal to 2. Here's theta. We'll use some different colors here. The inverse tangent. Now this is going to be my reference angle. Inverse tangent of square root of 3 over, we could put negative 1. I usually put positive 1. This way I don't have to worry about the absolute value bars. So the inverse tangent of square root of 3 over negative 1, that's a y over x. Which should be negative 1 over square root of 3, y over x. We've got that. Yep. See, here's our b over a, right? b over a. So negative 1/2 square root of 3 over 2. That's definitely quadrant 4, positive, horizontal, negative, vertical, and that's a pi over 6 angle. So confirmed. And that's why we want to be thinking of this. See, this looks like a pi over 6 angle, right? I would say it's an 11 pi over 6 angle because it's in quadrant 4. So these are the things that we want to think about. And then when you're doing the math, you can confirm and say, look, I did x over y instead of y over x. You catch your mistakes. It helps you learn. It helps you understand more deeply the connection between the algebra that we're doing in blue and red and the graphical representation that I have on the graph in gray. So we know that our angle in quadrant 4 is going to be 11 pi over 6. And n, we're raising this to the 4th power, so n is 4. So here we go. We've got z to the 4th power equals r, which is 2, raised to the 4th power, times the quantity cosine of 4 times 11 pi over 6. And I'm going to do that in my head. 4 times 11 pi over 6 is 22 pi over 3. So I sine of 22 pi over 3. I'm going to definitely need to find a coterminal angle for that. 22 pi over 3 minus, I'm going to subtract out 2 pi. That gives me 16 pi over 3. We'll subtract out 2 pi again. And that gives us 10 pi over 3. We'll subtract out 2 pi again, and we get 4 pi over 3. So this is the same as saying 4 pi over 3. So we have 16 times the quantity cosine of 4 pi over 3 plus I sine of 4 pi over 3. You can keep it 22 pi over 3. Doesn't really matter. You can keep it 4 times 11 pi over 6. But the fact of the matter is that you need to determine your ordered pair, and it's most easiest to do that by finding the coterminal angle 4 pi over 3. So we've got 1/2 square root of 3 over 2, and 4 pi over 3 is going to be in quadrant 3, so both of these are negative. Now remember, this 4 pi over 3 is not where the point is located, okay? So this 4 pi over 3 is not where the complex number is located. It's not the same quadrant. This 4 pi over 3 is a result, the 22 pi over 3 is a result of multiplying the quadrant angle of 11 pi over 6 by 4. So we have 16 times, the cosine of 4 pi over 3 is going to be -1/2. The sine of 4 pi over 3 is negative square root of 3 over 2 times I, and -1/2 times 16 is -8. Negative square root of 3 over 2 times 16 is -8 times the square root of 3I. And you can see that is what we have up here in the top right of our screen. So that's how we get the answer, -8 minus 8 times the square root of 3I.